Good afternoon and welcome to today's Machine Design and Industry Week webinar. Our topic today is leveraging manufacturing intelligence for product development, sponsored by A Priori. I'm Bob Vavro with Endeavor's Design and Engineering Group. Let's talk about how you can participate in our presentation today. If you have any technical difficulties during our session, simply type your issue into the Ask a Question box and a member of our team will assist you. You can also click on the question mark help button in the upper right-hand corner of your screen. We also welcome your questions during our event today, and we'll get to as many of those as we can during the Q&A session that will follow the main presentation, so feel free to send in your question at any time. To do so, simply type your question into the Ask a Question box and hit the Send button. If you'd like a copy of this presentation, please click on the Event Resources tab on the side of your screen to download the presentation. Also, please be aware that today's session is being recorded and will be available on the Machine Design and Industry Week websites within the next week. You'll be notified by email when the archive is available. We're really pleased to welcome Stephanie Faraday today. Stephanie's got more than 20 years experience in driving high-growth software businesses in corporate and consumer markets. Prior to joining A Priori 14 years ago, she's held executive-level positions at marquee startups and Fortune 500 technology companies. She's been exploring the possible at A Priori, helping to push the upper limits of the innovation curve in the industrial engineering, aerospace, and automotive sectors. So, Stephanie, we're looking forward to this presentation. This is of great interest to our audience, and we appreciate you taking the time to speak with us today.
Great. Well, thanks so much for the introduction. So what I'd love to talk to you about today is the next wave of digital transformation. And we're seeing it really being enabled by having manufacturing intelligence at your fingertips so that you can bring it in to help you at every point in the product development process, starting with the earliest stages of the concept of new products all the way through to production. So we're going to go through a few things. So let me quickly walk through the agenda so that you know what you're going to hear over the next hour. We're going to talk about the case for digital transformation in manufacturing. Manufacturing is really taking the world by storm in adopting digital technology. So we're going to take a look at that. Then we're going to touch on the fundamental steps for digital transformation. We'll follow up with digital transformation as we see it from our point of view. We have a really phenomenal opportunity to work with some of the world's largest and greatest customers as they're going through this digital transformation. And then Pat O'Brien is going to join us to take you through the technology and how the technology really makes this real and is helping customers to accomplish this digital transformation today. Finally, we'll open it up for Q&A to answer your questions live and in person during the session. So without further ado, I'll take you through what we're going to touch on in terms of the case for digital transformation in manufacturing. Many of you who are involved in manufacturing day to day know that the changes for manufacturers continue to escalate. If you looked at over the last few years, there have been events that have impacted manufacturing companies time and again, year in and year out. Even going back 10 years ago, you have events like Fukushima. That was 6,000 miles away from us, at least, and impacted Japan. It impacted the automotive industry in Japan in a significant way. But it also impacted global manufacturing companies who were in the automotive space. Fast forward a few years later, and there were volcanoes that impacted air traffic and other conditions. Then beyond that, you have some of the government regulations that were being introduced. Certainly the Trump tariffs played a role in some of that, as do some of the new standards around carbon emissions. The labor shortages have come into play significantly. I think we're all facing that. Coming out of COVID, the economy has just taken off. And the need for skilled labor is at higher levels than ever, especially as companies are starting to move into this digital transformation. The kinds of resources that companies need today are very different than they were 10 years ago. You have, we talked a little bit about regulations, but you have the whole environmental wave where everyone is looking to see what role they can play in reducing carbon impact and increase sustainability. So as you look at all of those things, those are sort of the economic, environmental challenges that companies are facing today. But then you have the same time just the business challenges that manufacturing companies are running into. The need to continuously create and develop new and high quality products to address customer needs. And those needs are evolving. How many of you ever thought that, your refrigerator would talk to you and tell you when you were low on milk? Or, your kitchen would give you a view as to who's at the front door. The types of products that are coming to market are not only advanced from materials and new manufacturing processes, but from innovative technologies and electrical components, as well as as chips to enable a lot of the dynamic internet interactions. Staying competitive and having the right price performance ratio versus competitors is also key. So from a competitive landscape, even if you look at the dynamics of the competitors today, that's changing significantly. If you look back 20 years ago, who would have thought that automotive manufacturers might be competing with the likes of Google, for automated vehicles? Or who would have thought that we would have startups in this space that are challenging the likes of some of our longstanding aerospace companies? So you have startups like Tesla, Blue Origin, and others that have just come out of nowhere that are changing the status quo for how people are competing in the market today. And that's also driving the need to innovate faster and to take market share. Lastly, delivering on products on time to avoid customer churn is really the fallout of a lot of this. With products changing so rapidly and customer demands maturing so significantly, it's more important than ever for companies to be able to bring products to market very quickly to capture that market share at the moment in time that the opportunity avails itself. So if you look at digital transformation, the transformation itself has been driving many organizations to look at how their businesses are running. So if you looked over the last few years, digital transformation was starting to tick up. Companies were thinking about how they could automate processes, move a little bit more quickly. But in the last 18 to 24 months, it's really taken on a whole new life. In fact, 82% of on-premise organizations have moved very quickly to respond to some of the recent economic disruptions. Those have accelerated the digital transformation of their business. So 82% of organizations are really focused on taking advantage of this digital transformation. And then 83% of those organizations who are already involved you have 39% of those who are delivering results right now. And so that's a rapid, remarkable acceleration from 2 years ago. And why is that? Well, we're working with a number of large companies, and the kinds of impacts we're seeing are those that Accenture has noted in their article. So about 20 to 40% are seeing a reduction in overall time to market. So if you think of that challenge we just talked about a few minutes ago of needing to gain that opportunity to grab share, digital transformation is helping companies really reduce overall time to market by significant amounts. And some of that is related to the fact that companies are able to move from the traditional physical processes like prototyping to digital processes. And that's having a huge impact, reducing not only prototyping time, but testing time, because they can iterate faster on the digital prototypes and get the feedback with many different simulation technologies that are available at your fingertips to get that feedback over the course of an evening, rather over the course of a few months or longer. And certainly the cost associated with that is significantly less. Not only is it reducing time to market, but it's also reducing costs. The digitization approach, where you're able to bring in the information associated with the CAD model, the manufacturing data, the simulation data, all into the same place and carry that through the whole product lifecycle, is enabling customers to move through their R&D processes faster. we're seeing customers take manufacturing intelligence like design for manufacturability or design for cost, or even in the future, design for sustainability, to feed that into their design while they're doing the design. Because as we all know, after the design is done, about 70 to 80% of it is locked in, and it's very difficult to make changes subsequent to that. But on top of that, it's not just about reducing R&D costs. So you're getting your products to market faster. You're reducing that late stage churn. So you're allowing your engineering team to move on to the next release. You're also able to reduce material costs right up front. As you're going through the design phase, you can see the impact on material. Or as you're going through the sourcing phase, you can talk to suppliers about the options that they have and what they can do to help reduce material costs. That's particularly important in today's market with the supply chain disruptions we're seeing, getting access to commodities with, truck embargoes like we're seeing right now. Those are things that are impacting many manufacturing customers. And so being able to be nimble and think about what alternatives do you have? What other material? How can you reduce the amount of material that you might need? All of those are things that companies who are adopting digital transformation are able to take advantage of right now. And if you think about digital transformation as you go from that concept phase all the way through to having the project live and in the market, we're seeing that there are really 3 steps to deliver the business impact fast. The first is to design right the first time, and integrating multidimensional characteristics like FEA or cost or design for manufacturability. Those are all critical inputs that you can get feedback on very quickly right during the design process and leverage those real-time insights. And with our customers, they're leveraging the insights right from digital factories. Those factories look like the real thing, but they're able to look at the manufacturing ramifications on design as you're going through the whole product development cycle. So they get that information at the right time to make an impact. It also enhances on-time delivery, streamlining the sourcing process. So we're seeing a lot of companies now looking at how they're changing the way they work with suppliers to move away from just a fact-based negotiation to a collaborative interaction to bring insights from the supplier into their processes and enable them to bring better products to market faster. And then optimizing the overall design for manufacturing and assembly process, thinking about the actual manufacturing operations, providing product design, sourcing, manufacturing, and supplier teams real-time digital insight is what carries it across the whole product development cycle. So let's break that down a little bit and look at, well, what does that mean from a design engineering process? What is happening in the world of design engineering as they're going through digital transformation? And then we'll talk a little bit about sourcing and what we're seeing happen there. So on the design phase, we're going from the world of long product development cycles to short product life cycles. Example of this, we were talking with a recent automotive customer. They were working on enabling a faster time to market because they were seeing that there were new capabilities coming to market. So they went through a very rapid design cycle using an agile approach that I'll talk about that enabled them to get to market so much faster. The data they provided was that a typical automotive design cycle might be about 4 years, a few years ago. Well, that's now down to 20 months, incredibly shorter. And then a typical car model might have been on the market for 8 years. Well, that's now down to 4. So if you think of the old way of doing business where companies would design their products, they would get them to the stage where they needed to be sourced, they would engage in a fact-based collaboration with a supplier. They would negotiate a 3 to 5 year deal where over the 3 to 5 year deals, the cost would go down and they would get to the optimal price. They would have a couple more years to take advantage of that margin to feed back into the business. Well, if you think of the example I've just talked about, where the design cycle is only 20 months and that model is only on the market for 4 years, that margin opportunity has gone away. So while the short product life cycles are really advantageous, we need to think about how to bring the rest of the product development cycle and the go-to-market engine into the whole ecosystem to ensure that we're driving margin in the same realm. Product maturity was reached during production ramp. Well, again, we had customers that would come to us and they would say, our product design cycle, anywhere from 20% of it to 40% of it, meaning of the time from when they start the detailed design to when it goes to be sourced or manufactured. 20 to 40% of that design phase was wasted in late stage churn. That's what they called it, late stage churn. And it was this back and forth where, they'd get it just about to go to production and they would have, it would have a manufacturability issue. So it would have to go back for rework, or it would come back in and maybe the cost isn't quite at the margin, at a level that supports the margin they were looking for. And so there would be this iterative back and forth that drove this churn. Well, with simulation and digital prototyping, being able to feed that data right in during the design, that information is being fed into the design during the design process, really eliminating a lot of that late stage churn, which is great. So that helps reduce that design cycle, but it also results in a product that is a better quality product that's delivered to market in a shorter time frame. Thirdly, stage gate waterfall. So this is the stage gate process of product development. And still a lot of companies do this today. They have the early detailed design phase, and then they go into the maturity phases of stage gate 1, stage gate 2, and eventually they get to the end of the stage gate and it goes to sourcing. Well, what we're seeing, the leading innovative companies who are really adopting digital transformation is taking more of an agile waterfall approach. And so bringing in cross-functional teams to those stage gates, and so that they can look at all of the aspects of the product maturity from a multidimensional perspective. But then supporting that is the digital transformation they're bringing in, that design for manufacturability feedback, that FEA feedback, the cost feedback, so that as they're going through this, they can look at the design with a 360 view as to the attributes of that design and how it's going to meet the broad market needs while still meeting form, fit, function, and time. So, it's enabling companies to factor in many more characteristics to enable them to drive a much better, much faster path to bringing products to market. And this siloed data model was the old world. This is really changing to what we're seeing as becoming one end-to-end product data network along the life cycle. And I talked a little bit about it a minute ago when I was referring to that agile stage gate approach with all the different constituents coming in. But data is being pulled from across the product life cycle. We're seeing companies even build these data lakes where data from the ERP system is coming in, data from a priori is coming in, data from the PLM system and the CAD system is coming in, from the simulation technologies. And they're all being moved into a data lake for new kinds of cross-functional analysis that feeds into that agile stage gate. So it's becoming this one end-to-end product data network, not necessarily by linking technologies, but by bringing data together. Sequential development and design, and you've already heard me allude to this as I've been going through some of the steps in this digital transformation that we're seeing design engineering go through. It's moving away from this sequential development design cycle to this ecosystems-based approach. And this is where you see a lot of what I just talked about come into play. But in addition to that, we're also seeing these digitally mature companies or companies on the way to becoming digitally mature start to embrace their ecosystem partners in the evolution of their products. So one of the things, if you think back about the evolution of the manufacturing industry, and I think this is self-evident to many of us, but go back 20 years ago, and I had a great conversation with one of our French customers a couple of years ago where he was articulating that 20 years ago, he would reach across the aisle as a design engineer. He would tap on the shoulder of the guy across the aisle, and it was the manufacturing expert. And he would ask him questions. And he, manufacturing expert, knew all about the new and innovative manufacturing developments, the new machines that were coming out, new materials that were becoming available, and they could feed that in real time into the design process. Then he told me, 10 years later, that was still possible, but we'd have to walk down the street because they started to outsource and his suppliers were in the neighborhood. We would have those same conversations. Well, now as you go beyond that, our ecosystems are global. Suppliers are all the way around the world and, are in many different time zones. So what we're seeing these our digitally mature customers do is start to bring their suppliers into the design process and into the sourcing process at the earliest stages of sourcing to provide insight into design changes based on manufacturing innovation that they're seeing in their plants, new materials that they're starting to work with, what they see other customers doing. And so moving to an ecosystems-based approach is becoming something that we're seeing ramp up across the industry. And then, moving from when you were, bringing a product to market in the old days where you bring it to market, you have, 2 to 5 years to get the cost down and get to the optimal side. That's no longer possible. We had one customer who, during COVID, had a product that was marginally profitable before COVID, but then as they started to come back into production after COVID, that product line was no longer profitable. Cost structures had changed. The lines had to be set up differently, and they were no longer profitable. So, they used a priori to help bring their costs down. But the epiphany for them was that we can't wait. It's got to be done during the design phase, and that's what we're seeing happen across many of these digitally mature companies. Is bringing that insight into the design phase that used to be happening after. From the supplier perspective, it's been an interesting evolution. I think as we go back 4 or 5 years ago, many of us started to hear about this concept of supplier collaboration. It was no longer about fact-based negotiation. There was the percolation of a conversation about supplier collaboration. And so if you look at the evolution of how we've worked with suppliers over the years, you go back 20 years ago and it was about, more of a transactional interaction with little transparency. I need a cost, give me the best quote you have. And then beyond that, as they move, as the whole world as we started to hear about supplier collaboration, we started to see this more dynamic interaction between buyers and suppliers. Companies setting up their tier 1 suppliers, getting more operational insight into what was happening at the suppliers, more ongoing interaction, and starting to see some moderate transparency. And where we saw this happening was, transparency between our customers and their suppliers started to be instantiated in, digital factory representations of their suppliers right in a priori so that they could start to iterate and collaborate faster. Now that's gone even much further, where we're really seeing it become very strategic. As I mentioned a minute ago, bringing suppliers into the design phase, high strategic interactions with a very significant degree of transparency, even to the point where, we've got some of our suppliers are now with their digital factories, they're giving the digital factory that has a significant amount of financial transparency right to their OEM customers because they've built a strategic relationship with them. They're looking at not only providing products, but providing strategic insights to help them guide in their engineering process. So this whole relationship between the way it used to be from tactical negotiation to where it is now with this evolving role of having suppliers as strategic partners is driving what we're seeing as shared business outcomes with faster results. So if you looked at what the fundamental steps are of digital transformation, I think McKinsey did a good job of articulating what we're seeing as well. And so I thought I would use their insight here. First of all, as you could hear from what I've really talked through that we're seeing with many different companies in the industry, is to create that digital thread right at the beginning of the design process. You've got the CAD model. You start to include information that's associated with the CAD model. So model-based definition really becomes more of a fact. Working with digitally native partners, as I mentioned, this whole dynamic between what's going on with OEMs and their manufacturing community, it's becoming more digitally native. It used to be days where suppliers may or may not get a CAD model. Well, that's becoming more the modus operandi, as well as sharing much more information in a digital way to enable both sides to go faster. Supporting all of that, it really has to be around ensuring that you have the right digital tools. And then lastly, or fourth, making sure that you and your manufacturing partners both have a digital transformation strategy. It's hard to do it without everybody in the queue being involved in understanding that digital transformation strategy. Supporting this is cloud computing. The digital twin, as I've talked about, is a key part of this. Automation, robotics, additive manufacturing, artificial intelligence, as they're all critical technology building blocks to not only automate the product design process, but the manufacturing process, and then getting feedback from the market. So we see different companies starting at different places, but it all seems to be building out to encompass these 5 steps in their journey along to get to digital transformation. So we see manufacturing intelligence now playing a very significant role as enabling that digital thread, because one of the first things we see is that the manufacturing intelligence about manufacturability issues, how you're going to make it, what it's going to cost, that manufacturing intelligence really helps to connect the product developments to production silos. So those data silos that I talked about earlier, they now have a consistent set of data to work from through the whole process. So if you have design for manufacturability and cost data coming out of the new product design process, sourcing can even get engaged earlier. They can start looking at, well, the product is still under design, what capabilities they might need from their supply base, so they can start having those supplier conversations earlier, or looking for supplier partners that they might need to make these products that are coming down the pipeline. And that's really critical if you think about those collapsed product design cycles that we're seeing. Individuals from all departments and roles can work faster and more intelligently by leveraging the manufacturing intelligence by data in the other role. I just gave you that example. I jumped ahead. This is an example where sourcing can leverage what engineering is doing, and it enables the whole NPI process to go faster. Suppliers can also benefit from that. If they're brought into this ecosystem exchange, they can be seeing some of the things that are coming down, and maybe even providing that feedback I talked about a minute ago to improve the designs so that they can manufacture faster, there are fewer DFM issues, and it comes out at a much different cost. We had one customer who has started to, they did a great job with fact-based collaboration in the design phase. And as they get to the end of the new product design and they started to engage with customers, they were able to drive a lot of costs out. But they were getting to the point where they felt that there was more that could be done, because it stopped where the gap in that interaction was. Nobody wanted to sort of exchange that little bit of more transparent information. And so what they did in some of their most recent interactions is they brought the manufacturing intelligence from a priori, in this case, into that conversation. And instead of having a conversation about, okay, here's the labor cost, here's the material cost, here's the overhead cost, they had a conversation about the manufacturing process. How much is grinding? How much is finishing? What machines are you going to be using? And what they discovered through that process was, unbeknownst to them, there was a lot of additional grinding going on that wasn't needed. And the supplier, and they asked the supplier, well, why are you doing that? Well, there was something on one of the drawings that suggested it was needed, when in fact it wasn't. And so by bringing this data, it enabled the two parties to align out, resulting in a very win-win situations for both parties, where it dropped the cost down, but the supplier got to maintain the margin. So it's, again, just about working off of a consistent set of data that brings information together that wasn't currently available across the constituencies. And then lastly is the driving alignment across the product development cycle by leveraging the same manufacturing intelligence across all the roles. That really, all of these things are really, we're seeing accelerate overall business productivity and bringing products to market faster. So, I thought you might be interested in, taking a little bit of a look at how we do it, but more importantly, some examples of the success that customers are having. So, the way that a priori works today is really by bringing the insights from the CAD model, the product design itself, closer to production with design for manufacturability and design for cost data. And that really enables companies to accelerate this whole time to market and accelerate time to revenue while reducing costs. Pat is going to take you exactly through how this happens. But let me show you a couple of examples of how this happens with the technology that we're delivering to market. So from our direction, we're really moving forward in the cloud. We see many of our customers moving to the cloud, even in the defense space. We're seeing them talk about what their strategies are going to be over the next few years because of the dynamic interaction that enables across all the constituents in the product development cycle. So to support that, we're bringing a range of products to market over the next 18 to 24 months. The first is already on the market with Cost Insight Design that really provides that visibility for the design engineer into the costs of their designs, but more importantly, manufacturing impact. And they can see that in a very visual way on their model. And once they see that, we can make suggestions for why it's a problem and what to do to mitigate it. We also have information for managers about, if they look at their product lines or their subsystems, where are the issues? Where are they relative to their target cost? From a sourcing capability, we're able to enable that fact-based collaboration, as well as that digitally manufacturing intelligence-enabled collaboration. For cost experts, we're enabling them to cost faster and cost more accurately. And then for suppliers who are participating in this whole interaction and are under as much pressure to respond quickly as the OEMs are, we're enabling them to quote faster and quote more accurately by enabling them to build digital factories in a priori that represent their manufacturing capabilities. And that enables all of the constituents who are using our technologies to share that digital manufacturing intelligence, to collaborate, to benefit from the automated analysis, the workflows, and the notifications that happen between the different constituents. So as promised, let me take you through a couple of examples. First, this is an example on that early phase that I just showed you with for Cost Insight Design, which is targeted at the design engineer. So this aerospace company had limited resources and they needed to identify parts that were at risk for quality and cost, but they had to do it very quickly and they didn't have the team to do it. So the build team used a priori to identify manufacturability issues. They ran their CAD parts through a priori. It presented them with a visual view in the CAD model to show them where the issues were. And as a result, it pinpointed opportunities for cost reductions, as well as opportunities to simplify the design. Now, what they did to ensure that that was correct is they took a priori's DFM analysis, that design for manufacturability analysis, and validated it against their manufacturing experts' insights just to ensure it was lined up. The good news, it worked really well. And we were able to match and even exceed the analysis of the manufacturing expert because we could do more. We can just do it so much faster, anywhere from a few seconds to a few minutes. And so now that aerospace company is looking to really dig into a larger scale application of DFM. But this resulted in a savings of over $3 million over the lifetime of the parts that they worked on, just in this one specific example alone. So again, this is using it during the design phase. And so you get those costs out before you get to the point where they're committed over the long term. Carrier is a different example, more in the heavy equipment space. So they had a very interesting scenario. So they had a difficult task of analyzing costs for a really diverse range of products. Their products were very technical. So for example, their screw rotors inside the compressors are very difficult to manufacture. They have complex geometries. They have extremely high tolerances in their designs. The rotors require multiple production processes, including gear hobbing, grinding, stock machining for the tail shaft. So it's a very complex component to try to do a should cost on. And so tools like Excel's, spreadsheets, or other traditional tools just couldn't do it because they really needed the insights from the CAD model to enable them to figure this out. So they identified a priori, and they actually are using us across 80 different digital factories in our software. And those are the ones that they've utilized out of the box. Plus, they've created some of their own. And what that's given them the ability to do is to analyze these parts for the first time ever in a very rapid way, and understand the cost impact of different designs. So as a result of using this, I think they talk about how they've gotten their accuracy into sort of plus or minus 5% for, on average for what they're doing. But they're also finding significant savings as a result of being able to get in using all of the many geometry details that are able to be highlighted in technology like ours, to the point where, on one set of screw rotors, they identified 200,000 in savings. And then on a broader basis, they've identified a potential for over $1 million in savings. And that's just over a subset. So these are the kinds of things that automated technology that's used during the design phase can have a significant impact on. So they're able to feed that data back both to the design engineer and to the sourcing team. Now, where they're going beyond this is to enable the design team to start getting that earlier feedback more frequently in an automated way, through some of our sister products. And on top of that, they're also looking at using something that we call Zero RFQ that a number of our customers have started to do, where they've created digital factories representing their suppliers. And they're able to go through the design process, get to the end, get a quick quote, send it to the supplier. The supplier looks at it and said, yep, this is good, or no, it's not so good, you need to make this change. But it's reduced quoting times for some of these customers from a couple of weeks to a few hours. So these are the kinds of benefits that customers who are really using us in their, even in the cost engineering phase across the organization is really expanding their impact. And then on the quoting side, companies like Flex are using us to quote faster and quote more accurately, to respond to customers. So this was a presentation that Flex did at one of our user conferences, and they had a manual quoting process previously. It was your typical Excel and homegrown tools. And they brought us in to help their sheet metal process, to look at how we could help them automate that. So they allowed a couple of benefits. Not only did it enable them to quote faster, but enabled them to quote consistently across regions. They're a very large contract manufacturer. It ensures all of the operational processes are aligned to the quotes. It really gives them the ability to flex, to forecast, with material requirements factored in, and with the ever-changing prices for raw materials. So this has really improved their quoting ability significantly, to the point where it's improved their win rates from 15% before a priori to 68% after. And the time to quote has been reduced significantly. So again, helping to accelerate that overall time to market, but helping improve the business benefit. So now I'd like to turn it over to Pat for the demo, so you can see all of this in action and see that it in fact really works.
I'm going to do a demonstration here of some of the technology that we have to offer, how we can integrate with your existing systems, and really kind of just talk about this product lifecycle digitalization, the digital thread of information, when we're referring to these kind of catchphrases, if you will, in modern times. So what you'll see up on the screen here, first and foremost, is really where this digital thread begins, right? I'm actually in a CAD system here currently. So the primary focus of this product digitalization is to basically remove the need to push information through, I don't want to call them archaic, but tools that have been in existence for a long time, right? Do I have a 3D model in which I then generate 2D prints to then send to sourcing and then manufacturing? And it's really, as Craig mentioned earlier, this very serialized process. So if we have a digital twin of this product in our modern CAD systems now, how can we then leverage both that geometry and really all of the data that could be extracted directly from that digitalized product. That's really where a priori can come in and play a large role in all of your organizations and really connect the dots between some of these departments. So first and foremost, I do like to showcase that, right, you can see that right up top here, a priori is an integral part to these modern CAD platforms. You have the ability to push data straight from that design engineer's tool right into a priori. We can do this both in sort of a manual version, such as clicking on a button and physically launching an application. And we can take this all the way to the extent where the a priori tool is actually just interacting in the background with specific triggers, meaning that your team can actually generate manufacturability information, should cost information, ideal routings for particular components, in virtually a completely automated state. Now, from this CAD system, right, I'm going to shift gears a little bit right to the a priori platform itself. So, right, this digital thread, this digitalization of the product lifecycle really starts with that CAD file, and now I just need more information. So moving into looking at this product from both a design engineering standpoint as well as a sourcing standpoint, how is it that a priori can play a role here? So as I mentioned, we directly integrate with that file. So from here, I can immediately look at things like assemblies and dig right down into individual products found within the product being developed. Now, the a priori model, it only needs a few user inputs to generate a lot of data-rich content. In this particular example, we're looking at potentially die casting this component. We're going to source this at really whatever region we're interested around the world. A priori is able to overlay local data such as labor rates or overhead rates, even available machine types for specific regions around the world. We're then coaching the tool as to what is this product made from and what's that annual volume. With just a couple of these basic inputs from the user, a priori does a couple of things. It actually extracts the geometry of this part and predicts an optimal routing. So we can actually see explicitly how this part is going to be manufactured. We can see that complete start to finish, inclusive of the machining of that component. And then we can even see things relative to the actual cost roll-up of the component, right? We can see that the material is playing a really significant role in this particular part. Over 70% of the cost is simply driven at the raw material level. Now, because a priori is again, this digitalized version of this model and the digital thread's still intact, we haven't actually taken this 3D CAD file that lives in our computers. We haven't generated a 2D print and then sent an email for an RFQ. We're basically able to replicate a should cost model right within the tool. And the biggest benefit here is we can now iterate on this as well. So for sake of example, if we're focused on material for this particular item and we're looking to reduce the cost here, what are some things that could play a large role in the overall cost of a product? Well, in this particular case, materials number one, and then things that are downstream of that, things like the overhead rates or the labor portion that are going into that product, and in turn, maybe trying to optimize something like cycle time. Within a priori, we can save scenarios of items and basically iterate through different potentials from a manufacturing standpoint. In this case, I wanted to look at a couple of different materials that this part could potentially be made from. So we're looking at a few different versions of aluminum, magnesium, and a couple of zinc options here. And because a priori has all of the calculations really in the background that it's doing, we can actually sort this and say, okay, I want to understand what is the overall cost of this component in these other materials, but I'm also interested in the cycle time performance here, right? I don't necessarily want to go to a particular material that's going to take longer to cool from an injection or a die casting standpoint, and I certainly don't want to increase my machine cycles because I'm already up against the fence here from a throughput perspective. So I really want to optimize not only cost, but things like cycle time as well. Stepping into another part on this particular assembly, just looking at specific items and then iterating through not just materials and things relative to cycle time, but really allowing your teams to ask what if more often, right? If I back up and we look at this first image here, this original cover was actually designed as just an aluminum plate, right? We're just simply machining this from a solid stock, but having a tool like a priori allows your design engineers and even your sourcing teams to simply say, I've got a part in question. I think there may be a better way to manufacture this, but I don't have a way of quantifying it. So what we can see here is rather than having to, again, redesign the component, send it out for RFQ, and really kind of play the traditional game that we play today, what if we just were to look at a digital simulation of this? So I want to take this part and I want to cost this as a plastic injection molded component rather than a stock machine component. Just by doing that, again, a priori is going to reassess that from a manufacturability standpoint and come up with not only cost estimates, but things relative to cycle time, design guidance, right down to the tooling cost associated with that part. We can then immediately stack these things side by side. We can start to iterate in many different ways in the sense that this particular cover, we first looked at a stock machine component. Now we're looking at a plastic injection molded part. And we can see that we're able to not only reduce cycle, but we're able to dramatically reduce the cost here. Right out of the gate, this could potentially just be a directional exercise, right? Maybe we want to cost this component as a stock machine component from billet versus die cast versus plastic. Help our design engineers understand which would be the optimal process to focus on, and then start to shift the design of that component to best align with that particular process. One additional thing that I do like to highlight is I kind of pointed out those digital factory locations, areas around the world that we're able to cost components in. So just as I was illustrating, we can iterate through alternatives from a material standpoint, we can do the exact same thing for different regions around the world. So what I've done here is I've looked at actually identifying the cost of these components through five different tiered suppliers that we have, sort of our primary go-to low-cost regions and supply base. And for the components in question, we can quickly see that we, basically a total cost here, but we can quickly see that Thailand, Vietnam, and China are pretty well aligned for an overall cost standpoint, and that might be where we want to focus our efforts here. But we can quickly see, due to the present tariffs that we're seeing over in China right now, that this logistics cost is just simply making this component non-competitive in that region. So not only are design engineers and sourcing teams able to look at iterations on material types or even just entire process group types, in this particular example, we can matrix cost these parts through virtually as many regions around the world as necessary, or getting more specific with some of your strategic supply base to best understand where is the optimal supplier to source this part today, right now, right? Not 6 months ago, not 2 years ago, based upon our historical data. I need some real-time data to help you react to the changing markets here. Now, the last thing I do like to showcase is what we were just kind of going through was an individual assembly made up of individual components and kind of looking at the one-by-one details relative to those parts. Something that a priori does is, because we're able to look at all of this data and we are tied to that digital thread, once we step this up a notch and we start looking at actually automating some of these results, we can produce a tremendous amount of data in the background for your teams to then effectively filter through and understand where are some of the pain parts for whether that's product development or whether that's in the sourcing field. This particular example here is actually taking a current project and letting a priori basically do its thing. It's going to analyze components for what are we currently paying today for these components, right? We're cutting POs for parts right now versus after doing that mechanistic costing, what does a priori think these components should cost based upon various inputs such as material and region and volume? And then finally highlighting the potential for our sourcing teams to go after. Now, this example here, I personally work with a lot of pre-sales customers and clients, and I will say that this is an extremely common result. What we typically see is there's a few parts over here to the right where we're effectively saying the price you're paying today is actually really well aligned with that should cost, right? You're getting a very fair deal for that component. And it's encouraging to see some of them under the line, and it's really encouraging to see a nice flat trend line here because it just means that you're well aligned with your supply base. But something that we always see when we look at a large group of components, assemblies, product lines, or even commodity groups is we are going to have some outliers, right? These particular components here to the left, we're paying around $35,000 for the purchase lot here. We should be paying no more than $16,000 according to a priori's mechanistic cost model. What this really helps your sourcing teams do is pinpoint those outliers, and think of this as a fish finder, right? We don't need to spend our time on these components down here. The overall spend is relatively high, but there's really not a lot of wiggle room for what we could be purchasing that part for. So this really lets us kick things up a notch, filter through large arrays of data, and really help us understand where the opportunity is from a sourcing standpoint. We actually have very similar tools that are used on the design engineering side as well that filter through things like manufacturability issues. If I'm looking at 150 stock machine components, I want a priori to flag the components that are most challenging for my team to manufacture and really help either drive that NPI cycle to a more effective part right out of the gate from a sourcing standpoint, or even a VAVE standpoint, where are some of the opportunities on the current products that we're making today.
Great, so thanks, Pat, for that demo. And if anybody has any questions, feel free to contact Pat to enable, if you'd like to learn more. All right. And for those of you who want to learn even more, feel free to contact us, send 3 to 5 of your own CAD models. Once you do, we can tell you how to upload an FTP part, and then we can actually do a custom, show you with a custom demo of your parts right live and in action. So feel free to reach out to us, and there's no charge for that. We'd be happy to show it to you. Okay.
I think we've reached the Q&A session of our program, and we're now joined by Patrick O'Brien, the application engineer for a priori, and Stephanie will be helping us go through some of the questions here. You've submitted some questions already, but if you'd still like to submit a question, type it into the Ask a Question box and hit the send button. Also, please take a moment to complete the feedback form that is located at the bottom of your screen. Stephanie and Patrick, a number of questions have come in from the audience. We want to get to those at this point. Let's start with this. Can you explain more with a practical example how the digital thread is defined in the context of digital transformation and how it relates to the digital twin?
Yeah, absolutely. So I think one thing that we kind of mentioned in that demonstration video, really thinking of products as living and breathing within these systems now that we have at our fingertips from a digital standpoint. So having PLM environments that store sort of dynamic information, ERP systems that connect the dots between how products are made, what are our raw material rates, for example, and then really importantly, as Stephanie mentioned earlier, CAD systems, FEA platforms that are doing sort of not only manufacturing analyses, but even functional analyses now. Now, having that sort of an entire product, not just the pieces, not just the sheet metal parts and the machine components, but, getting all the way into things like PCBAs, wire harnesses, all of these products that are now built in a digital environment. How can we leverage that now? If we have that, do we have to still use these sort of traditional approaches of sending out RFQs, waiting 4 weeks to get a response, rather than simply having a tool that can tell me right up front as that design engineer is working on a specific component or product line, where is a target cost? What should I expect to pay for this thing? And then getting that answer very quickly, because we can now understand from a target perspective where we should be. And then once we start to receive these RFQs in sort of that rapid fire approach, we can start understanding where we're well aligned and where we're either missing from a target perspective, or where we need to maybe push back a little bit on our supply base, or just understand where we can find a better supplier for that particular part or particular commodity group.
Let's talk about another area. How much manufacturing knowledge is required for the user to leverage a priori's functionality?
So that's a great question. I think that's a really key component to a priori, is the fact that, and I hate to answer with absolute truths here, so I'm not going to say zero, but very little. Right? It's a huge benefit of leveraging our tool, is that the user doesn't necessarily need to know my supplier is going to run this on a 5-axis machine center with 60 horsepower and it needs 60 inches of throw. They don't need to know anything about that. All they need to know is I'm machining this part, period. I'm machining it, it's made out of aluminum, and I need roughly 40,000 parts a year. A priori does the rest, right? A key component here is we actually extract that geometry. So we're going to tell the user, here are all the bits and pieces that make up this component, and here's how you're going to make them. Here's how your supplier is going to make them. And most importantly, here's the optimal machine to do it on, right? So if we come back and say, your supplier should be running this on a 30 horsepower 4-axis machine, and they're doing it on a 15 horsepower 3-axis machine, well, there's a really good chance that's why you're paying 2x, for example, what you might be paying for that component. And another note there is that it's not necessarily related to simply machining. I mean, anybody in your organization, you might have machining experts, but nobody that has an idea how a component is die cast, right? A priori can really be that unbiased professional now within your organization to help you understand the optimal machine routings for anything that you're manufacturing.
Very good. And this is another really good question, and I think it speaks to a lot of what manufacturers face. Can you talk about the relevance or use of this software in a non-mass production application?
Yeah, absolutely. So something that we do have the ability to control, again, is sort of that annual volume input there. But another thing to consider is, because we have access to so many data points within the stream here, right? When I click that cost button, for example, I'm going to understand and I'm going to be able to visualize things like labor rates, things like individual setup times, meaning if I've got 6 setups for one part, I can look at setup times for each individual setup there, but inclusive of the overall setup time. So if I tell a priori, I need to make one of these parts, right? I need quantity 1 ever. It's going to look at all of those inputs and be able to calculate based upon setup times, based upon the tooling requirements for all of that. What is it going to cost to manufacture one component? And just by making a simple change to that volume, for example, it's going to be able to show the user how we can sort of amortize that out across the product life cycle. Now, this gets really clever and important when we start iterating through process groups, meaning maybe additive makes sense at an annual volume of 5 because I only need 5 components. But at what point does it actually make sense to go to machining or to go to a post-machine die casting? Having a priori, I can run 3 quick scenarios on that in various different volumes, and I can actually plot that, and I can see explicitly where it makes sense to deviate away from additive into machining and then into die casting. So fantastic question. We using that matrix costing approach and then leveraging sort of the volume input with a priori, it's something that's really powerful. A lot of our customers use today.
We got time for one more question, but I think it's a really good one. Does the a priori tool also include the possibility to digitally assess the certification process conformance versus the regulation requirements, such as materials used, product performance, et cetera?
So we can certainly look at material, so the certification process and conformance. So we have an out-of-the-box material library that customers can leverage. Another thing to note is that if you have unique materials, those are things that we can build into sort of these digital factories as well. As far as like a regulation and requirements, right? If you have to meet a certain specification, well, there's going to be a criteria that makes up that specification. And whether that's a particular secondary process, maybe it's a cleanliness, maybe it's a tolerance input of some sort, either building those into those digital factories or actually having, I mean, let's call it a button, right? If we need to conform to this specific regulation, what are the criteria that make that up? And then we can integrate that right into how we process that component with our tool. So if it's something, if you're looking for a pass-fail criteria, or these 4 materials are acceptable, whereas these 10 materials are not acceptable, because we have access to all of that data and we're leveraging things like material types, we're reading in tolerances from 3D CAD files. Because we have all of that information at our fingertips, it's simply how do we want to process that?
Very good. Well, that's all the time we have for our presentation today. I want to thank Stephanie Faraday and Patrick O'Brien from A Priori for great presentation. If we didn't get to your question during our Q&A session, we will be responding via email. So on behalf of Machine Design and Industry Week, I'd like to thank A Priori for sponsoring today's event. And of course, thanks to all of you for joining us. Have a great rest of your day and stay safe out there.